ionization energy differences. So let's say we had a horizontal comparison, AS versus SE. Okay. So with a horizontal comparison, we start off by identifying that they have valence electrons that are both in the same energy level. So we say, I'll do this in red, so we say both AS and SE's valence electrons, I'm just going to say VE for that, are in the fourth energy level. So we say N equals 4. Okay. So the protons in the nucleus of AS and SE are pulling on the fourth ring, if you will. They're not pulling on the individual electrons. So it's important to think about N equals 4 as its own thing. Okay. So then we go and we identify which one of them has more protons. So in this case, AS is to the left of SE. So AS has 33 protons in the nucleus and SE has 4. So we say that SE has one more proton. Okay. And I'm going off the script that I showed you guys in class. One more proton pulling on the N equals 4 electrons. Therefore, the electrons, I'm just going to abbreviate electrons like that, experience more pull and have a higher IE. Okay, let's go ahead and do a vertical comparison in this case. So I'm going to do SE and TE. So let's go ahead and do SE versus TE. Now when you're comparing something vertical, it's important to not focus as much on the protons, but you're focusing on the shielding of the energy levels, sort of protecting those electrons from the nucleus. Come on in, guys. One sec. So in this case, as you guys come in, do you mind being quiet for like 1 second? It's just as I finish recording this. Okay, so how should we go about doing this? Okay, so SE versus TE. So SE's valence electrons are in N equals 4. Okay, so we identify that. TE's valence electrons are in N equals 5. Okay, so TE's valence electrons are further from the nucleus. Okay, so then we say SE's valence electrons are less shielded. Okay, there's less shields of electrons in the way, and thus the electrons experience more pull. So we can say, therefore, the electrons experience more pull from the nucleus and have a higher IE. Let's go ahead and draw a picture of something really simple with this so you guys get the idea here. Let's look at B and C. Awesome. 1 sec, buddy. All right. So if you take B, B has 5 protons in the nucleus, okay? And B has 2 energy levels. So we're just going to draw those energy levels. There's N equals 1, and there's N equals 2. Now, C has 6 protons in the nucleus and 2 energy levels. But because there's an extra proton in the nucleus, it's going to pull harder. So you notice it's smaller. And what that means is if there is an electron here, it's going to be harder to remove. Okay? It's going to have a higher ionization energy. Both, notice, this is a horizontal comparison. So they both have 2 energy levels. but this one has 6 protons pulling. So because it's pulling harder, it's going to be harder to remove that electron. So we're comparing the protons to the energy level. Let's look at a vertical comparison now. Let's say we had B and we had the one right below it. That's Al. Almost done, guys, sorry. So we know that B has 6 protons in its nucleus with 2 energy levels. Al has 13 protons in its nucleus, but it has 3 energy levels. Okay? So even though there's more protons in its nucleus, those electrons are shielded by an extra energy level. So this electron right here is going to experience more pull from the nucleus and thus be harder to remove.